Okay, in this class I'm just going to very quickly introduce the concept of position. Okay, so here we have the 1961 Ferrari 250 GT California. I have it from a reliable source that less than 100 were made. Suppose this car moves around. I'm going to just put it moving in a straight line. Just straight line movement from right to left, or as close as I can make it with my kind of shaky hand here. So straight line movement from left to right, just moving along. And I want to kind of think about the position of this car. I want to be able to describe the movement of the car ultimately. You know, what's happening to it. You know, when I want to think about the position, in order to think about the position of the car, I need to kind of develop some kind of coordinate system. You know, I could say here that it starts at the right and moves to the left. You know, something fairly simple like that. But in order to examine different concepts like velocity, acceleration, all sorts of jerk, snap, crackle, pop, all sorts of different physical quantities, I need to have some kind of numeric system. So what I might do, and what we tend to do, is we kind of assign some kind of coordinate system, which if it's just moving in a straight line can just be as simple as a number line. So now I have my 1961 Ferrari 250 GT California moving along the straight line. Okay, so we can talk about that. It's just an axis, you know, maybe it's an x-axis, maybe we can just think of it as being the x-axis. It's only moving in kind of one dimension, left and right. It's not moving up and down. It's not, you know, doing circles. It's just moving in one dimension from the moment. So another thing I might decide to do is kind of assign some kind of numerical values here. I'm going to do this roughly. Of course, I should really, if I'm being accurate, measure these things out. But I might just choose, just start putting in some dashes along here. These really should be equidistant from each other. Not too bad, I suppose, you know. But again, your imagination, they're supposed to be equidistant. And then my idea is this. I'm just going to kind of think about something. I'm actually going to just take a quick copy of that number line because it's so wonderful. I'm going to just move it down here. Okay, so I have two number lines. And again, you know, when I'm thinking about my coordinate system, one thing I'm thinking about is maybe where is the 0 point on it. And that's a choice. That's really a choice. So I might just come along and I might say that's position number 0 here. So suddenly we start to get a picture of how we can describe the location of something numerically. The other thing I might do is name this point here. And one thing, I could name it anything really, depending on the distance. But suppose I measured that distance and it was 1 meter. Well, I might call that position 1. But I don't have to call it position 1. I could have called this 0, and I could have called this position negative 1, if it's 1 unit away. Either way, what we're doing, once we've chosen our 0 and one other point, we've kind of, nothing else is a choice after this. Okay, so my coordinate system is a choice. I decide where my 0 position is, and then I decide where position 1 is. Okay, and then that kind of forces everything else. This one can't be just any number at this stage. That has to be position 2, 3, 4, 5. And again, you know, we tend to use meters as the units of position. So if you can imagine these as being 1 meter apart. If I'd chosen this second coordinate system, if that's 0 and that's negative 1, well, this can't be 2 anymore. That would have to be negative 2 and negative 3 and negative 4 and negative 5. This would be positive 1, positive 2, positive 3, positive 4, positive 5. Okay, so it's a choice. We're more used to seeing the top one because it looks like those number lines from primary school, but there's no reason I couldn't develop a coordinate system that looks like the bottom one. The top one, because the numbers are increasing as we move to the right, this top coordinate system is called a right positive system. And this bottom coordinate system is called a left positive system. Of course, you could call it a right negative system as well. And now I can really start to describe things. So if I just shrink, I'm just going to shrink my 1961 Ferrari 250 GT California down a little bit. You can see there at the moment it's at position 5, and then maybe it travels all the way across here to position -5. Okay, so we have the concept of what we call initial position and final position. So we might call the initial position of this thing 5. Again, you're probably used to in mathematics, rather than writing out the words initial position, we tend to come up with some kind of notation. So one common notation, because we're using an x-axis here, I'm going to use x for position, and then just a subscript of I for initial. So we might say the initial position here is 5. Now if I was looking at my bottom coordinate system, well, on my bottom coordinate system I would describe the initial position of this car as being -5. And then the car will move somewhere. Okay, where? We don't know. Possibly somewhere in Chicago. Maybe it finishes over here. Maybe it stops there at position -2. So I might say my final position here is -2. So notice x for position and f just for final. And so we've got final position, initial position. If I look at my second coordinate system, my final position here and my second coordinate system will be +2. Okay, and in our course we're really interested in the change in variables, how things are changing over a period of time. So we might look at the change in position. And again, we mentioned the change in position before. The change, this letter here, this is a Greek letter, delta. Delta always means in mathematics the change in something. Okay, so delta always means the change in something. So this is delta x, which means the change in x. Well, how do we find the change in x? Well, we start with whatever our final position was, and we subtract our initial position. In this case, it would be -2, subtract 5, which would be -7. So our change in x, which actually has a name, which we'll talk about in our next lesson, our change in position is actually -7 in this case. What does that mean? Well, it means it's moved 7 units. Why negative? Well, on a right positive system, the negative is saying it's moved 7 units to the left. So this is telling me that we have moved 7 units left, because it's a right positive system. If I look at this second one here, I look at the change in x on my second coordinate system. My final position was 2. My initial position was -5. So my change in position will be +7. Change in position, +7. What does that mean? Well, this is a left positive system. So that is saying, in my second system, it's saying it moved 7 units left. So note that both systems, even though they're kind of the reverse of each other, both of them I can work out that this car has moved 7 units left if I know the initial position and the final position. That is what we call one-dimensional motion or unidimensional motion, just moving straight back and forward. Okay? But suppose, we don't want to just move straight back and forward. Suppose I want to move in a slightly different way. I want to move around some kind of flat surface, drive around a track. Well, what we can do, once we're moving, we've got another direction. Here we're moving both up and down and left and right. Okay, and I want to think about my position, because that is, of course, what we're talking about in this lesson, position. How can I describe my position? Well, just very similar to the way we do at kind of junior cert. Let me just shrink that right down so there's no kind of ambiguity over to where it is. If I want to describe, let's move it to here. Suppose I want to think about the position at this moment in time. Notice we have an x-axis and a y-axis, so maybe I might use the letter P for position here. So I'm going to say position initial here is equal to, well, at junior cert coordinate geometry you would call that 3, 2. We tend to call that 3 I hat plus 2 j hat. I hat is along here. J hat is up this way. So 3 I hats to the right, 2 j hats up. Okay? And again, my units might be meters there. So that's my position. And then I'm going to just change the position in some way. And, you know, maybe I move up here and down here. And then I finish up at position over here. So maybe my final position is over here. So what is that? Well, again, if you just think about junior cert geometry, that's -1, -2. What we would call that -1 I hat subtract 2 j hat. And again, we're always interested in the change of things, so I'm looking at the change in position. Here will be my final position, subtract my initial position. So, final position, -1 I hat minus 2 j hat, subtracting my initial position, which is 3 I hat plus 2 j hat. I'm going to open the brackets. So I've got -1 I hat minus 2 j hat, subtracting the 3 I hat and subtracting the 2 j hat will leave me with a change in position of, just like junior cert algebra, we combine like terms. -1 I hat subtract 3 j hat, 3 I hat is going to be -4 I hat. -2 j hat subtract 2 j hat is -4 j hat. Okay, so position is a quantity we kind of choose. We make up a quantity. You know, I didn't have to call this 1, 2, 3. I didn't have to call this 0. I could have put 0 down here and built from there. But it tells me not only how far something is in relation to some fixed origin, it tells me the direction it's in as well. So I can read this 3 I hat plus 2 j hat, and that's telling me that that's 3 units right and 2 units up. So it's given me a direction as well. So it's given me a distance, how far away it is. It's telling me a magnitude. And it's also telling me a direction. And when we have a quantity that tells us a magnitude and a direction, that quantity is called a vector quantity. It's not just telling us how far away it is, it's also telling us in what direction. Okay, so position is just telling me about the location of an object somewhere in space. By assigning a coordinate system to that space, we can describe the position mathematically in a numeric way. And that's kind of the first thing I want to talk about. Okay, so have a go at a few of the assignment questions from that section and see how you get on.